Quadratic gives you a parabola when you graph it. Garden variety, y equals, again, it was a times x squared plus b times x plus c. If the x is positive, it's an umbrella that opens the upwards way. Okay, if the x is, if the x squared is positive, a positive x squared will give you this. A negative x squared gives you the downward umbrella sort of look. Okay, in a parabola. Now, a couple things we have to define here. Okay. Smiley? Please. Please. Okay. Point number one here is what's called the vertex of the parabola. The vertex of it, just like with angles, the vertex is the place where it goes off into a different direction. This is the vertex of this one, and this is the vertex of the other one. Okay. In addition to that, well, the definition of the vertex is it's the highest or the lowest point. In this case, it's the highest point. In this case, it's the lowest point. Now, those things are also called maximums and minimums. Okay? If it goes like this, that point is called its maximum. And this point here is called its minimum, because that's the lowest it'll ever go. It's the minimum. The other one is the highest it'll go, so it's the maximum. Okay. Now, quite often when you see this, they will ask you to define, well, let me see where it is here, while we're talking about this. They are going to ask you to define what the set of x and y can be. Let me find it here. And obviously when I'm looking for it, I can't see it. Somewhere here, I'll find it, and then I'll go, oh yeah, there it is. Well, and what it means is this. If I asked you, if this were, first of all, these little graphs have arrows on them, which mean they go on forever in those directions there. If I asked you what possible values x could have, x is the set of what numbers? Okay, in other words, here's my x-axis with all my little x points on it. Okay, could x be -1? Yeah, because here at -1 it crosses that x-axis, x point there. Could x be 5? 1, 2, 3, 4, 5. Eventually this thing is going to get out there. X can be, in both of these graphs, x could be any number, all real numbers. X is all real numbers. We'll just throw up the letter R there that stands for all real numbers. Because it never ends. X goes on forever in both directions, and this thing is going to keep going, it's going to keep getting wider. Y, on the other hand, ladies and gentlemen, Y, on the other hand, what can Y be? Well, Y is going to be any number, and this one, Y starts right here, and it's any number greater than that. So we'd have to know, let's just pretend for now that that's a 2. Y would be any number that is greater than a -2. Because this is where y starts, and it goes forever going up that way. Comprehend-vous that? Y, this is the lowest y is going to be, and it's always going to be something number, because it goes forever in the up direction. So y is any number greater than -2. Whereas this one, if you look at what x can be what? X again could be any number because it goes forever on the x-axis in both directions. So x is all real numbers. Y, let's say this is a 3 up there. What values can y be?
A number less than
Less than or equal to 3, however you want to say it. Y is less than or equal to 3 because it starts here at positive. The maximum is at +3, and it can be any number down there. You good with that? They'll ask you somewhere along the line. I couldn't find it there, but I know they ask you that. Now, take a deep breath because we've got more. Okay, let me draw another one of these things here. Let's say you've got a graph here. And then let's say you have this here, and your parabola. Your parabola crosses here, comes down, crosses there, comes up. Quite often when they talk about parabolas, they will talk about the zeros of the function. And when they talk about the zeros of the function, they are simply talking about where does that function cross the x-axis. Where does it cross? Where does it cross the x-axis? Which only makes sense because where it crosses the x-axis is where y is 0. Okay, so if you're looking for the zeros of this function, they would be here at zeros would be at -2 and +2, because that's where it crosses the x-axis. That's where y is 0. If you put down the points, it would be -2, 0 and 2, 0. They are the zeros. If the parabola doesn't cross the x-axis, like this one, it has no zeros. No zeros. Or the other option is there an E at the end of zeros? Yes? If it's plural, there's an E? No, it doesn't. Not according to the book, it says right here. Your other option would be this. You could have a parabola whose max or min just touches the x-axis. In other words, it could look like this. Comes and crosses right there. I guess I missed that too. Okay, in that case, it would have just one 0, and in that case, the 0 would be 0, because it would be 0, 0. Or it's 0, because it crosses it. It kind of shoots up right there. How's that? So far, so good? So I think we just got one more thing there. And the last thing we have, when you have a parabola, let's make this parabola a little different, shall we? Let's say the parabola does this. It's off, kind of skewed there. The next thing is what's called its axis of symmetry. We talked about symmetry before, and that is basically nothing more than the vertical line. It's the vertical line of symmetry. Okay, which would be this. If I took a dashed line and went right down the middle, it's the line that makes it symmetrical, and I was hoping to get it right there at the number 2, but I kind of missed. Okay, the axis of symmetry in this case would be where x equals 2. Right there where it's symmetrical about. Now generally speaking, you are going to ask to find that axis of symmetry, and this is the formula you need to write down for that axis of symmetry. The axis of symmetry equals this. Write this down. Negative b over 2a. Make that in big, bold, beautiful letters in your notes, because that is very important. What does that mean? Anybody?
Slope?
It is not the slope, it's the axis of symmetry. It means this. If you go back to the quadratic, standard form of the quadratic equation, which is y equals a times x squared plus b times x plus c. Let's say you have an actual numbers in there. We're actually doing a real one where y equals 2x squared plus 4x plus 6. To find this axis of symmetry, you plug in b, which is this, for the letter b. You plug in a, which is 2 for the letter a. And when you plug all that in there, you will get the place where it crosses the x-axis for that axis of symmetry. So let's do that. Let me show you. Let's hope it's red. I love red.
So
So-
you shouldn't guess.
What's that?
So you shouldn't guess.
Well, they'll give you exact drawings of it, and then you'll be able to look at it. But no, they're going to give you an equation, and they'll give you something like this and say find the axis of symmetry. Which no, you're not guessing. Now you got to use the formula. So you do it. The axis of symmetry. Axis equals negative b over 2a. So b is right here. B is that 4. So you put negative 4 over 2 times whatever that is, 2a, which is 4. So negative 4 over 4 is a negative 1. Okay, so x equals a negative 1. When you're graphing that thing, here at negative 1 is where you draw that dashed line, and that's what the parabola's axis of symmetry is. It's going to be symmetrical about that point. Now, they don't tell you how to find the zeros from it, so we're going to get to that a little bit later, but whatever it is, you know that it's symmetrical around that thing there. We don't get to the actual graphing of these until a little bit later, but you need to know this little formula. Right
So
here.
I didn't guess yesterday. I was in the math.
Did you have one on the math test?
Yeah, I had 3.
Did you get it?
No.
I wouldn't suspect you would. I think that's all they're going to ask you to do. So look at page 588, and we'll talk